Hello and welcome to this week's edition of Nourishing the Planet, a webinar series connecting climate science and nutrition from DUville University. My name is Casey Stewart. I'm the Program Director for Health, Wellness, and Climate. And this is really a collaboration between the program in Health, Wellness, and Climate and the program in Nutrition and Dietetics. So really trying to address this gap in resources and educational instruction by bringing these two fields together. And so today we have Mark Rifkin, who is a nutritionist and registered dietitian, and is going to be helping us think about plant-based solutions. So his talk today is Hope Through Beans, Our Plant-Based Patterns, Our Best Tool Against Climate Change. Welcome, Mark, and you can take it away.
Thank you very much, Casey, and thanks also to your colleague, Nahid. So I'm going to share my screen. Okay. So let's see. So hopefully you see my slide without
I
notes.
do. Yes, you're all set.
Very good. So as Casey mentioned, our title is Hope Through Beans. Our plant-based patterns are our best tool against global climate change. So throughout, I will be referring to global climate change as GCC. First, a little bit about me. I've been a registered dietitian for about 20 years. I specialize in plant-based dietary patterns and their practical applications, especially for nutrition and sustainability. And I'm the author of a recently published article in Frontiers in Nutrition. Our objectives today. First, we'll review basic chemistry of greenhouse gases, or GHGs, and how they relate to global climate change, GCC. We'll discuss the bidirectional relationship between GCC and food production. We'll itemize reasons why the current policy and social focus on fossil fuels should be redirected toward food. We'll highlight concerns and benefits of local and regenerative practices. And finally, we'll identify reasons why replacing beef with chicken is not necessarily an effective solution against GCC. So this may appear to be a bucolic image of cows grazing in the Rocky Mountains. However, those aren't the Rocky Mountains. The mountains are actually cow manure towering over a feedlot in Nebraska. And the U.S. produces well over 1 billion tons. Yes, that's a billion with a B, tons of untreated animal waste per year. But I could not confirm current detailed production data. Why is manure so important? For two reasons. Number one, beans don't poop, and neither does any other plant food. Number two, because it releases methane, one of the primary greenhouse gases. So speaking of greenhouse gases, or GHGs, how do they actually alter temperature and climate? So after the sun's energy enters the Earth's atmosphere, the planet warms, and some of that heat is re-irradiated back into the atmosphere. Gases such as CO2 or carbon dioxide, shown here and here, as well as methane, shown here and here, absorb and hold on to some of that heat, while some is lost. That absorbed energy is what is heating the atmosphere, altering climate and precipitation patterns, all of which is termed global climate change, or as I'm abbreviating, GCC. The term greenhouse effect is used because the effect is similar to a greenhouse. And I can testify from personal experience. I was in a greenhouse on a summer winter day. It was about 20 degrees outside and about 80 degrees inside. The effect is the same with cars during summer. We all know, have seen that and felt that. So warming also generates what are called positive feedbacks. Not positive as in good or beneficial, but positive in the sense that the effects further drive the original cause. In this case, those are increased wildfires and loss of reflective polar ice. Fires, of course, release even more greenhouse gases, and the loss of the reflective capacity of polar ice increases heat absorption, all of which further increase global climate change, and thus a positive feedback. So the most commonly discussed greenhouse gas is CO2, or carbon dioxide. And this pie chart shows the major sources. Note that virtually all of it is from energy generation. That is heating homes and businesses, fuel for cars and trucks, and similar uses. Ag is there, but it's such a small slice, it doesn't even show up. Contrast that with major sources of methane. Ag, shown here in blue, is just about the same size as energy generation. Methane in ag originates partly from manure that we saw before, but also from cow burps. When does a cow burp? Every time it chews its cud, which could occur several dozen times daily for each cow. Multiply that times 100 million cattle per year. Why is the difference in sources so important? Overall, carbon dioxide emissions are many times larger than that of methane. So you may have also heard that CH4, methane, is a more potent greenhouse gas than CO2. That's true. So in order to compare them, it is common to express methane in CO2 equivalents, or what is abbreviated CO2e, shown here. Exactly how much methane is equal to how much CO2? Over 100 years, which is the most commonly applied timeline for comparison, the effects of methane are about 23 times that of CO2, shown here. But there are real concerns that the more appropriate timeline is 20 years, since methane generates major impacts before it degrades over that 20-year period. So if we shift the timeline to 20 years, methane is 85 times as potent as CO2, shown here. Because of its high potency in the short term, it can be easily argued that the focus on CO2 should at least be shared with methane. But perhaps even that is an understatement. So carbon dioxide versus methane, which is a better target? So CO2, as we said, is far more abundant than methane, but 96% of that CO2 is from energy generation. But CO2 emissions are locked in the existing policies, industries, and infrastructure. Locked in essentially means it's not easily shifted in the short term. For example, do most people have the money to buy an electric car? I know I don't. Are there legitimate concerns about viability of electric vehicles? Definitely. From retail price to environmental and human rights impacts of the battery materials, to the need to install literally hundreds of thousands of charging stations and retrofit residential households to accommodate charging functions. Can we even produce enough electricity to meet the demand of electric vehicles? And that's without increasing greenhouse gas emissions. And roads and streets may not safely and easily accommodate bicycles and scooters. I personally know of a high school friend who died in a car accident while cycling. So even if we encourage more use of bicycles, what's the impact on gas tax revenues that fund highway and road maintenance? Do we need to license bicycles to replace that lost gas tax revenue? And solar panels may be a great idea, but do most people have the means and the opportunity to install solar panels? What if you live in a small house or a multifamily building? Shall we install solar panels in rural areas or urban areas? Meanwhile, wind power installations are being challenged as damaging bird and bat populations, as well as what we call viewscapes, which are the visual aesthetics of certain landscapes and coastlines. Not to mention our entire energy infrastructure, which was built to extract and transport fossil fuels and then generate and transmit fossil fuel energy over long distances and under city streets into residential and commercial systems. That cannot simply be easily and quickly replaced to accommodate wind, solar, and other low emissions technologies. We might be able to answer and address these concerns and questions, but that's not going to happen in the short term. Because of lock-ins, the tasks and timeline to change the fossil fuel infrastructure are substantial. Contrast that with the logistics to replace methane. which is largely dietary change, which largely means dietary change. So we'll look at the data to showing impacts of dietary choices in a few slides, but for now, for the 85 to 90% of the non-institutionalized US population who are food secure, the obstacles are mostly social and cultural. Given changes in knowledge, food environments, and cultural attitudes, then behavior change for most of us could happen within a year or two. We don't even need new cookware. Now, not to minimize the sociocultural issues, but once those are addressed, we simply make different protein choices. Yes, that will require changes in production practices, supply chains, employment, and training, but those changes are mostly a matter of scale, not of developing novel technologies from nothing or realigning the roads in our cities and towns. So ultimately, methane, which is substantially, as mentioned, driven by agriculture, is a relatively simple change. Thus, reducing methane via dietary change is the quickest path and provides the best ROI, return on investment, to slow global climate change. That's an important point. So society and policy makers are ultimately looking at the wrong greenhouse gas. I did mention food security a bit ago because that is also a huge part of the question. So let's look at some details. So food production is a key driver of climate change and thus a key part of the solution. So even if fossil fuel emissions were eliminated today, emissions from the food system alone would make it virtually impossible to reach any reasonable target for moderating or minimizing the degree of climate change. But climate change is also altering food production via changes in food production volumes, the geography of production, that is where food is produced, crop vulnerability to predation and disease, and spoilage, all of which, of course, impacts food loss and food waste, which is has its own impacts to global climate change. And of course, what we witnessed just a few years ago due to COVID is just a dress rehearsal for the likely impacts if we do nothing to address global climate change. Next, let's review expected impacts for 4 major crops. So these are 4 major crop impact maps under business as usual, that is, without any major policy changes or lifestyle or changes in lifestyle choices. So these are again expected yield changes expected within the next 50 to 75 years, as compared to a baseline of 1980 to 2010. Deeper blue here represents increased yields, while deeper red represents decreased yields. For the US, notice we see relatively modest declines for rice, but significant declines for corn and soy, and severe declines for wheat. Notice all the red in here. Notice especially that the severity of the decline for corn throughout much of Central America. How will this manifest in this country? We're already seeing those effects: increased forced migration and social and political conflict, not to mention increased risks to well-being, safety, and security for the individuals forced to migrate because an indigenous crop is no longer economically viable in their home country. That is an important point that is often missed. Next, let's look at 2 potential food-related solutions for global climate change. So the USDA defines local as within 400 miles, but many others, institutions and agencies use other limits. Unfortunately, various transport modes generate different impacts. For example, the greenhouse gas impact per pound of potatoes shipped 1,000 miles by rail is about the same as the greenhouse gas footprint to ship potatoes 100 miles by truck. So you can ship 1,000 miles by rail for the same greenhouse gas footprint as 100 miles by truck. So therefore, 1 mile does not equal 1 mile. Longer distance does not necessarily mean higher greenhouse gas footprints. According to one originator of the food miles concept, food miles are not a very good measure of the food's environmental impact. As it turns out, most of the greenhouse gas impacts of a food are in production. Local buying would probably generate a maximum of 19%, and perhaps as low as 4%, depending on the article one researches. So despite these popular false assumptions, local may not have much, but local may have actual non-greenhouse gas values. For example, for the socio-cultural dimension of sustainability, which is helping people connect with their producer, understanding more about production, fostering community around food and food culture. Also, the economic impacts for producers, who are often small. And then you have the health and nutrition impacts, because nutrients and flavor may be lost every mile. Meaning a child finding joy in eating a local peach has benefits far beyond the joy of a bag of chips. But there's just not much reduction for greenhouse gas footprints. How about regenerative? So regenerative ag practices are intended to sequester carbon in soil, thus potentially reducing greenhouse gas emissions and global climate change, increasing soil moisture, thus reducing losses to evaporation and runoff, and enhancing biodiversity of soil bacteria and related insects, arthropods. Some RA practices commonly include not tilling, because tilling breaks up soil, accelerates erosion, reduces biodiversity. So that's called basically a no-till practice. Using cover crops in between crop cycles to reduce erosion and add nutrients. A cover crop is planted not to be harvested, but to be incorporated into the soil before planting the next production crop. And then there's crop rotation, which reduces loss to insects. And then there's using compost, crop residues, and other natural materials to add nutrients, moisture, and biodiversity. But RA has its challenges. First of all, the definitions and the criteria vary widely. What is or is not included in regenerative ag? Yields are often lower versus conventional, which of course requires additional production and therefore generates additional greenhouse gas impacts. Many conditions apply which may reduce or negate that soil carbon storage, which they are dependent upon as the primary reason for its impact on greenhouse gas emissions. Grass-fed beef versus factory data show the same or higher greenhouse gas emissions for grass-fed as it does for factory. That is per kg beef. So in other words, but the benefits of grass-fed are basically minimal, if not zero. Manure generation, of course, we've already looked at the fact that manure generates substantial methane. And of course, if we were transporting it, that generates health and safety impacts. And RA ultimately may generate only a fraction of the carbon sequestration needed for actual impact on global climate change. However, that doesn't mean we shouldn't practice regenerative ag. We should do it anyway. And we should continue to research it. So even if the greenhouse gas reductions are not evident, we can generate other potential benefits by maintaining soil quality, biodiversity, and moisture, and reducing agricultural chemical usage. So those benefits can still be generated with use of RA. And of course, RA does not exist in a vacuum. RA can exist alongside dietary change to generate multiple benefits across multiple metrics. But I encourage conscious consumers not to expect RA to generate significant reductions in greenhouse gas emissions, which takes us to the question of exactly how diet changes can actually impact food and nutrition security and land use. So here we have a graphic of a simple model of a food web. Trophic levels are the individual levels, shown here, in which a relatively large volume of producers supports a smaller volume of primary consumers, which in turn supports a smaller volume of secondary consumers, and so on. Therefore, animals and people that eat only plants are primary consumers, while carnivorous animals are secondary consumers. Note some species may occupy multiple levels. For example, omnivorous humans. But why do trophic levels shrink with each step up the food web? So on this side of this graphic, on the left side of this graphic, we see producers and food consumed. But all of the food consumed is not actually digested and absorbed. Much of the losses are in the form of body heat and fecal waste. The actual calories used for body growth of the primary consumers shown here are only about 10%, i.e. this arrow, this portion of the food digested. Although the 10% proportion doesn't really represent well here. And the same thing happens in the transfer from the primary to the secondary consumer, shown here. So at that point, the biomass is only 1% of the original food consumed from over here. Guess what else is lost with each step? Nutrients. That has obvious implications for food and nutrition security, as well as optimizing use of ever scarcer resources in food production. Here we have a more specific depiction. The mass of each box is the amount required to produce the mass of tissue in the box above it. So this amount of grain is required to produce this amount of primary consumers, which is required to produce that amount of secondary consumers. Can it be defended for humans to primarily be secondary consumers here? Or does prioritizing resource efficiency demand that we primarily or exclusively be primary consumers here? By definition, fundamental principles of ecology indicate that species who are primarily or exclusively primary consumers are the default winner for optimal resource efficiency. So how much calories and protein are lost when humans eat common animal foods? So this table shows that for common animal foods, 75 to 97% of the original calories in the feed are lost by the time the human eats that animal food. 75 to 90%, 97. This waste is maximized in cows, somewhat less in hogs, and lower still in chicken, eggs, and dairy. The proportions lost for protein and total mass of feed wasted are similar. Notice that even when feed waste is minimized, in the case of chicken meat, that still amounts to 50% loss. That means 50% of the value of all the labor, all the water, all the chemical and fuel inputs, all the hazards generated to farm laborers were essentially meaningless. That, of course, also means animal waste and biodiversity losses were generated unnecessarily. This is a summary of inputs and outputs based on UK data. Theoretically, US figures could vary slightly. Each metric compares the impact of various dietary patterns versus high meat eaters, which are reflected as the black dots shown here on the far right, with set as a standard of 1.0. Low meat eaters are consuming a maximum of about 2 ounces a day. Medium meat eaters are consuming about 3.5 ounces a day as a max. And high meat eaters are defined as consuming more than 3.5 ounces a day. Meat includes pork and poultry, but not fish. So the dots on the lines represent averages, and the line through the dots represent the standard deviation, or the variation from the average. So as compared to high meat eaters, we see steady and progressive reductions in CO2 equivalents, again, greenhouse gases, as animal food intake decreases. up to approximately 75% for the vegan diet. Because of the huge amounts of feed required, reductions in land and water footprints and biodiversity losses are similar. Is everyone familiar with eutrophication? Shown here. Eutrophication is the process in which nitrogen and phosphorus accumulate in a body of water, resulting in an increased growth of algae that eventually removes oxygen from the water, which ultimately kills fish and other marine life. That's the cause of the infamous dead zones in Lake Erie and 400 other locations around the globe. Where does the nitrogen and phosphorus originate? Comes from urban runoff, wastewater treatment plants, eroded soil, but most especially chemical fertilizers and manure. But we don't have really good info about how much comes from which source. But one thing we do know is how much manure we produce in total. And of course, we know that beans don't poop. So this is a graphic depiction of the dead zone in Lake Erie from 2005, which is the latest year for which I could find an image. Deeper red indicates higher oxygen concentrations, while deeper purple represents oxygen concentrations so low, essentially nothing can survive. Thus the term dead zone. The water is fundamentally dead. And here, of course, you can see a rather substantial dead zone in the center of Lake Erie, probably about, 300 miles southwest of Buffalo, which would be up here. So manure, of course, is one primary source of nutrients driving eutrophication. And animal manure volume from chicken production is estimated at approximately the same as beef cattle. But chicken manure is 2 to 3 times more concentrated with nitrogen and phosphorus than cow manure. So that eutrophic water releases up to 30% of global greenhouse gases. But those greenhouse gases are not counted in national databases, including the United States. And of course, those greenhouse gas emissions induce GCC, global climate change. The GCC, of course, itself induces an algae bloom, during which the initiation, magnitude, duration, and distribution increases via alternating cycles of drought and intense storms, higher water temperatures, and increased temperature variation. So climate change itself drives eutrophication. So here's a graphic depiction of the process from the previous slide. Water with high nitrogen and phosphorus becomes eutrophic with algae, releases the greenhouse gases, and ultimately we have a feedback loop shown here. Eutrophication releases greenhouse gas emissions, which drives climate change, which further drives eutrophication. This slide is another reason why chicken intake under global climate change is not necessarily a solution. So we've already seen these numbers from the previous chart. We know that it wastes 66 to 80% of the feed's nutritional value. But chicken are especially sensitive to heat stress, as might be expected under GCC. So the chicken meat actually wastes substantially more nutritional value under climate change, and particularly under the crowded conditions typical of modern industrial production. So that even greater loss of efficiency results from reduced feed intake, reduced growth, and ultimately reduced feed efficiency. And of course, aside from increasing environmental inefficiencies and greenhouse gas footprints, reduced production is likely to result in higher retail costs. And that's unrelated to inflation. So is chicken really the solution that it's perceived to be? No, not really. So ultimately, sustainable dietary patterns will reduce, if not eliminate, animal protein. And any animal protein that is included should be mostly low-impact choices that have limited greenhouse gas impacts. such as shown here on my plant-based model for omnivores. Note that half the plate is non-starchy vegetables, shown here, cooked or raw, prepared in any way you like. 1/4 of the plate is whole grains and starches, shown here, which also includes potatoes and corn. And the remaining corner of the plate is the protein, which is the primary generator or saver of greenhouse gases. So if plant protein dominates and animal protein, especially beef, becomes a condiment or an occasional choice, then we just might produce a much smaller greenhouse gas footprint. So to summarize, methane reductions are more impactful versus carbon dioxide reductions to reduce global climate change. Methane reductions are more achievable versus carbon dioxide, and global climate change is already impacting food production and food security. Local and regenerative practices may have benefits, but there's no evidence versus global climate change. And based on trophic level principles, efficiency is optimized if meat intake is reduced, if not eliminated. And global climate change will further worsen greenhouse gas impacts of low impact chicken. Thank you very much, and I look forward to your questions.
Thanks so much, Mark. That was really great, really interesting stuff. So I've got a couple questions and some comments, and then we can kind of move on. So one of the things that's kind of really interesting to me is that it's when when we're talking about animal proteins, from an agricultural standpoint, we're really looking at transporting and producing the thing twice. And so it's I'm interested in how, once we produce the corn in the field and all of the emissions that it takes to, drive the tractor and then, harvest it and then transport it, if we're just feeding it, in some feedlot again, is that getting captured in these numbers that you're looking at?
Yes, so let's see. So if we go back to this slide here, um, so in these two articles by Weber and Matthews and Lee, they took into account the production of the feed itself,
Mm.
not just the transport of the cows, for example, or transport of the product to retail or to institutional um, distributors.
Yeah, no, that's so interesting, the way it really just gets doubled and compounds. Um, I also wanted to ask, there has been a cultural shift. There's a few cultural shifts happening. There is, I think, a popular awareness of plant-based diets and plant-based alternatives. But there's also this real emphasis nutritionally on protein. Everything now has protein in it.
Yep.
And so I'm kind of curious your thoughts. I mean, you've kind of focused this on beans as a real savior, but I'm wondering about other meat alternatives that kind of, are more processed, thinking about your Beyond and your sort of the fake meats that are found at the store. What kind of impacts are those having, and sort of, environmentally and nutritionally, how are you thinking about those?
So we have good data on that, um, both environmentally as well as for health impacts. So for health impacts, a study just came out in the last year or so comparing unprocessed red meat to these more processed plant food products. And the health benefits were substantial.
Hmm.
Um, that's despite the fact that a lot of these processed plant foods have added ingredients that, say, the average consumer, is not likely to be able to have in their kitchen, and B, their excess sodium content, which I do believe is a legitimate concern.
Hmm.
But based on the data, the benefits for for the average consumer are so substantial compared to even unprocessed red meat, much less processed meat. In other words, the nutritional bar set by red meat is so low, even a Beyond Burger is better. That's one
Yeah.
way to look at it.
Oh, gotcha, gotcha. No, that's really interesting, and helpful. Um,
So
so
to
I was also wondering, what do you have recommendations? You know, you had that last plate, kind of showing, you know, the proper proportions. Do you have
yes,
any recommendations for a great meal that maybe, you know, our viewers out there can try to make themselves?
absolutely. So well, let's take your Beyond Burger. And as I understand, they have modified some of their ingredient profile to make it a little bit more, like, well, let's say a little less unhealthy. Um, so if I'm not mistaken, a typical Beyond Burger, somewhere between say 15 and 20 grams of protein for a typical burger. So um, so that's obviously going to occupy this quarter of the plate. Let's say we have 1 cup of a whole grain starch. I'm going to use rice, even though it's not as nutritious as barley, but let's say a cup of rice. And then 2 cups of veg of pretty much any variety one might choose. So you got roughly 15 to 20 grams of protein here. You got roughly 2 or 3 from here. You've got roughly another 4 from here. So you're looking at somewhere between 20 to 27 grams of protein per plate. For the average American male, I'm looking at roughly 60 to 70 grams of protein per day. Divide that into 3 meals, you're looking at roughly 20 to 25 grams a meal. I just did that, 20 to 25 grams a meal right there. So now if one wants to avoid, or let's say not use Beyond Burgers, which I would encourage people to say not make Beyond the core part of their diet. Let's go beyond burgers. Um, let's say tofu. So if one chooses a relatively firm tofu that is contains more protein, less water, that's roughly 14 grams a serving. Again, you're looking at roughly the same numbers.
Yep.
You could do the same thing with beans. So let's look at, say, 3/4 of a cup of lentils. You're going to have about 14 grams of protein. Again, that's in addition to the contributions from the other parts of the plate. And then multiply times 3 meals a day. So now in terms of the current obsession with protein, yes, I and many other knowledgeable advocates are concerned about the impacts of the recently issued dietary guidelines. Um, I will add that 85 to 90% of the population is what we call protein replete. In other words, they are clearly getting enough protein based on accepted standards. Now, of course, the new dietary guidelines challenges the standard and say, well, we actually need twice what we thought we needed. Well, knowledgeable advocates, including PhDs, are now challenging the issuance of the guidelines and challenging their lack of quality evidence. And in fact, behind the issuance of the dietary guidelines was the Dietary Guidelines Advisory Committee, one of whose members I'm proud to say I helped nominate. And the Dietary Guidelines Committee, which was again composed of roughly 20 individuals without clear conflicts of interest. And once they assessed the data and analyzed its various impacts and nuances, issued a statement, an advisory report, strongly advocating for increased plant protein intake.
Hmm.
That's separate from the group that the agencies brought together to actually write the guidelines most recently. So I and others are actively seeking a formal process to reconsider and ultimately repeal the recently issued guidelines.
Got it. Yeah. Wow.
Ultimately, um, they are catering to not only industry interests, but also what I would call the relative nutrition illiteracy of the average American, who is obsessed with protein, while they pretty much ignore the fact that more than 90% of Americans are substantially deficient in fiber.
Hmm.
And how this, of course, is one of the big dichotomies of the recently issued guidelines, is they're recommending fruits and vegetables, and they're recommending people eat more fiber, but then they're also recommending all this meat and dairy. So those two components, you might say, are inherently contradictory
Hmm.
because, of course, meat and dairy contains no fiber. So, um, nor does chicken or eggs. So, how are you going to get all that fiber without incorporating substantial plant protein, specifically beans? You're simply not going to be able to do it. It's not a workable equation. Although I suppose one could, just chow down on Metamucil and other fiber supplements. That's not really a viable option for many reasons.
Fascinating. Fascinating. Well, that's great information. So thank you so much, Mark. On behalf of everybody here at Duville and everybody out there and on the internet, thanks for this great talk, and look forward to talking more with you soon.
Thank you, Casey. I look forward to further conversations.
Excellent. Thank you.